はい、それではこれから各ソフトウェアの、説明に入らせていただきます。時間も限られておりますので、重要な機能および、最近の改善点を中心に、主に説明させていただきます。まず最初、冒頭は、宣告システムでございます。本日説明させていただく内容としては、このハブシステムから e シェアへどのように出力をするか、あとは、プロファイルの一括作成機能、あとは、デッキ上に配置された機器が、いかに連動して動いているか、あとは、日本でよく使われている外反転回路をどのように作成するか、あとは、ビューアーの機能改善、繰り返しになりますけど、NAPA との連携強化、あとは、OCX 変換を通じまして、選球協会の 3D 承認作業、こちらがどのように行われているかや、FDM 計算用のモデルに変換すると、といったような、機能等の、紹介させていただきたいと思います。それではお聞きください。
Well, welcome everybody. My name is Olaf van der Akker. I'm the technical manager for CADMATIC Hull applications, and I will show you the CADMATIC highlights. The content, first something about Hull to eShare, few things about basic design, import NAPA steel, interoperability, shape and shelf, and construction. Today we already have seen eShare passing by, and also my colleague will also give a presentation about this. And a new part from the CADMATIC Hull is the publication of sheet drawings and of course class drawings to CADMATIC eShare. The publication for Hull for breakdown sketches to CADMATIC eShare for the production. For the Hull breakdown sketches, all levels can be exported, of course, with the production information, and the metadata is exported as PDF, like profile sketches, profile list sketches, and of course also reports if possible. The basic design. Designing in 2D for basic design is the most used option when faced with tight deadlines we still see at most shipyards. Sketching helped us to understand the proportions, scale and the relationships that are difficult to see in 3D. So, when we have those sketches, why not use those 2D drawn lines for the 3D model? So, sub-bulkheads and longitudinal bulkheads can be created by converting those drawn lines at the floor or deck level to steel plates. The system builds the 3D model automatically and searches for the 3D boundaries of the steel plates to be created, and of course they are all fully topological as they are all related to each other. After the creation of the bulkhead, each bulkhead, main or sub, can have assigned properties so that the material and stiffening structure will be available and visible in the views. Profiles can be created as plate properties, and a series of profiles in cross-section can be created in one go. The system will create all profile on grid positions which are not occupied by other construction. If the grid is changed, for example with distances, the profiles will move or disappear if a certain kind of grid distance is not there anymore. Profiles can be easily converted to production profiles with one simple click by selecting the bulkhead. Next to that, we can create a series of pillars in length and or in breadth on a deck level, all in one go. The only thing the engineer has to do is provide the direction and the distance and the amount of rows. The system automatically searches for the end relations, the end limitations like the deck below. All these 3 steps or topics will be covered tomorrow in the workshop. Something about the basic design, sorry. The last development for the basic design is that the equipment can be placed in CADMATIC hull. Heavy machinery layout influences the ship weight. The equipment library provides access to the outfitting database. The equipment is displayed in the hull view and can be positioned as required. The nice thing is that outfitting and piping disciplines can access the same model, making adjustments or changes according to the machinery requirements. Equipment can be connected to a hull view. Change of the hull view level will move the equipment. For example, you work in a view, let's say at a width height of H3. You create construction in this view. You connect the equipment on that view. After that, let's say that H3 is the tank top. The tank top have to move slowly in height. The grid value is changed in the system management, and after recalculating and updating the views, all the equipment is automatically moved along. Import Napa steel construction. We already have seen it a little bit today. The developments on the CADMATIC side, if we import Napa steel, the thickness direction from Napa steel construction is used nowadays. All plates are fully topological, so if there are certain kind of parallel distances used in Napa steel or offsets to surfaces, they will be created as parallel distances in CADMATIC, so no auxiliary lines or arcs are used. Seams, butts and shell plates can be included in the import. Corrugated construction imported as a corrugated profile or a corrugated bulkhead, depending on the corrugation limit set in the system management. All those developments are all based on the latest Napa steel design. Here is some Napa steel import example. This is, as you can see, clearly a submarine. On the left, a mainframe as an example. The above Napa steel, below CADMATIC hull. Next to that, an armchair, for example. On the left over here, we have some shell plates with hull line boundaries, which can be imported. And on the right, an example of all kinds of corrugated bulkheads in different directions. Interoperability. The export to the OCX XML format. Open class 3D model exchange defined by DRV Germanic provides the basic functionality of exporting 3D constructions and meant to allow classification society to use for approvals. A fully topological to the OCX format. The process improves, of course, the drawing-less strategy in the shipbuilding. They are having direct access to the 3D model, improves the understanding of the design. And all parties involved in the vessel have direct access to the model, no creation of dedicated drawings anymore. As you can see on the pictures, CADMATIC hull, you make an export, it can be opened in Nauticus hull from DRV classification, and after changes like certain kind of property changes, those can be back imported into CADMATIC hull. The export to the OCX XML format. The same format from the export can be used to import the construction in HyperWorks for FEM calculations. So it's eliminating the need of meshing the model inside the CAD software. And presently, of course, the naval architect needs to prepare a time-consuming meshed model of the vessel to study the steel constructions. Study the steel stresses, sorry. Same picture on the right, but then with the HyperWorks, you export the OCX, you load it in the HyperWorks for the FEM calculations, and afterwards it can be imported again in CADMATIC Hull. Then a few small things about shape and shell. As we all know, maybe not all, but as the people know who work with CADMATIC, is that we always use a hull surface-based shape. Those shapes are always created in external software. While creating those shapes, normally you will have to create boundary lines and or intersection lines. That's nowadays not really necessary anymore. If a surface is overlapping, intersecting or connected to another surface, then those intersection lines are automatically created within the CADMATIC Hull software. The same is for the hull boundary lines. If a surface without any knuckle lines, etc. is imported in the software, those lines can be created automatically after updating the shape. Shape and shell, but it's also quite new. CADMATIC Hull has always had, of course, the 3D shell expansion. Many customers are still asking for the 2D classic shell expansion, so that it is now possible within the software. In those views you can create shell plates and of course shell frames. So basically, if you create shell views in one view, you can create from the center line to the top in one go all the shell frames. And for example, all the shell plates like this. In this view you don't see the construction, but of course is there construction, you also see the construction. Then we go already over here. For the construction, it is now possible for the engineer to create enclosed plates in view. The enclosed plates in view will be the default in the shell application. What does it mean? That with one click a topological plate or shell plate can be created. On the left you see the input panel from the 3D application, on the right from the shell application. You only have to fill in the thickness, and like in the picture over there, you click somewhere in the middle of the area. Doesn't come really precise, just somewhere over there, and the plate will be created. And that were my highlights for CADMATIC Hull.
続きまして、アウトフィッティングのパートのご説明になります。同じく機能紹介、あと改善、状況の紹介等を行っています。設計区画ごとに、ルールを設定した上で、ミスのない、機能紹介をさせていただきます。
Hey, good afternoon. My name is Marko Kuusela and I'm showing you today some features from CADMATIC outfitting. What are the new directions what we have taken last couple of years? So first I would like to talk to you a little bit about our web API interface. The main idea on the web API interface is that CADMATIC has now created a good solution and interface to other systems. such a way that, as you know, that nowadays shipyard, you have really different kind of solutions. You have PLM solution, you have project management, document management, equipment management, all different kind of tools, and they all are having same information many places. And now we don't want that CAD solution will store own data and they have a separate same duplicate data. So our new interface, which one is laser? What? Pointer. Oh, thank you. Oh, yes. Yes, IT. Yes, so the new interface is now all about creating a nice tool where we can connect for CADMATIC model data, document data, all different data we can be able to extract from other softwares. From PLM, we can get the data directly from CAD solution to available for project planning, for work preparations, for document management. And also, other way around, we can push data inside CAD solution. So we can get from, for example, PLM, we can get item list, we can get every catalog information ready. Same catalog information, not duplicate, same data. One source of truth, only one data, no errors. For PLM document management, we can retrieve document directly from our database. Or we can push document directly to our database. Many different things what we can now utilize that we are easily integrating to any other systems you have already. We have now good interface for that. Yes, then something about outfitting. First, one big step what we have getting more better and more general feature is sistership management. You are always, not always, but very often building many series of ship. One prototype, many similar ship, small changes all the time. We have now created a tool where we can easily keep the same design from the proto, update from the proto to the sisters, or from the mothers to the sisters, and also same time keep local modifications. So we can have one main design where we can then make changes only certain part in the sisters. And this of course keep going. We can still here maintain even though local changes is happening. Same goes with documentations. From the document we can also same way handle that this is common document for mother and sister, separate local documents for sister only. So we can, as long as possible, we can make common design for all series. Another very big thing what we have started to all different kind of improvements that we are going to virtual environment. This is the future. This is the future for small shipyard, big shipyard, small engineering office, big engineering office. This is something what already is happening. Already we have been doing it, but we are now more clear start to support virtual desktop and virtual environment. We have inputted the performance that once you are using virtual, it will be then as it would be used normal. What means virtual? Virtual means basically that there is centralized computers online outside of your company or inside your company, but we are centralizing the computing power. Everything calculation will be happening in one big computers, which then in your laptop you only connect to that big, expensive, very fast machine to make work. Your laptop can be old, new, different version, very old version, doesn't matter. The virtual environment where you are going in is up to date as it should be. There is a lot of benefits of this. First of all, very important, improve data security. Normal laptop no longer have data. It is only portal to place where the data is. IT has much more possibilities to secure the data. Nobody can copy data here because they are not having anything how to retrieve the data. It is there behind a remote desktop. It's like looking through the window. You can see but you cannot touch. You can modify but you cannot get. System stability. There is a dedicated IT department who can take care of this environment all the time with backups, everything. If this computer crashes, no problem, we take another from the scratch and he connects with new computer to ready-made environment. These will be becoming obsolete. Doesn't matter which machine you are running. Very important. Also for big and small companies. For big shipyard, they have already this one, maybe. They will already have this one. They will have a lot of data saving because this is only thing where they are pushing money. These can be very cheap old terminals. Very big data saving, much easier for IT. For small companies, you don't have to have your own data center. You can buy from Azure Cloud, easy. You just buy a cloud, you put your environment there. From this, even from small company, very fast to start. No need to worry about IT personnel. Backup, everything much more easy. Yes. Then, secure for designing. We have enabled tools which will make your design more secure. We can not only that people are only one person can edit same time. That has been 20 years ago. But now we can use for certain roles, piping designer, what you can do. Electrical designer, what you can do. Are you able to edit this? Are you able to edit this? We can apply the creation, modification, deletion. Who has access? Who can? For example, easy example, if you are piping designer, only piping process related model objects. No electrical can be touched. No structural design can be done. System access, no can do. Hi. Simple, but effective. We have improved our whole 2D document production tool. It has been totally renovated, new. New interface, now new engine. It works .dvg layout like AutoCAD drawings. Similar base, similar syntax. This means that all layer configuration very common from AutoCAD. We have made a lot of improvements for drafting, so it is like AutoCAD. because people have used. Dimensioning, hatching, everything very similar, very easy to use, very fast to use. Much better layer support. And very important, we have improved a lot our change visualization. Every time you go and edit a document, you can easily visualize. It will show colors, old, new, changed. You know where to concentrate. Streamline work with Model 3. We have also listened to our customer. They have wanted to have like e-browser like visualization 3. So we have implemented, for example, this Model 3, where you can visualize the structural way the component. Same way you can have work breakdown structure, you can have whatever kind of hierarchies, and now you can visualize systems accordingly. While creating different kind of groups, for example, work preparation groups, everything, you can make them system-wise. You can make them hierarchical-wise. Also for visualization, much easier to locate it from the tree, or from the tree locate the model. Okay. These all have been done for better and faster user experience. Then something also very important, maybe a little bit smaller, but for people who are using very important, we have automated the bolt length calculations. So nowadays system can have intelligent way to determine correct length of bolt. Because that is actually a huge material loss when you have too long, and very irritating if you have too short. But now it should come optimal way. Also, what is nice is that you can see directly orientation and everything from 3D. No need to check from any documentation that what is the orientation. For structural design, small but also efficient, different kind of modifications. We are nowadays allowing to make holes, different cuttings, also the beam shapes. Very simple picture, but it tells you a lot. Snipings, cutting with other objects, so you can see two beams, so it cuts the actual seam line. So when you make production drawing, you can see the actual cuttings here. Holes, of course, once you have isometrics, once you have support drawings, you also, very bad picture, but you can see the holes, dimension the holes for easier production documentation. And what for administrator, it is much easier to administrate than before. Also something big is the Boolean operation. What it means that for shapes we create in CADMATIC, now we are able to create holes and cut Boolean cutting operations to the primitives. Especially here it's very good example when you have a tank. Previously this tank you could not drill a hole inside, but now you are able to actually more better visualization to see how the pipe is going through there. Here is just a small example that how you can make extraction, so you can have one part which is cutting from another part pieces. Or here is a beam which has gone through the object, so you can see the holes from both ends. It's going through. But this is now possible for much better visualization and also dimensioning and production documentation. Then, small thing but very big thing. Already longer time ago, maybe you all have noticed that we have changed our pipe route assistance to be very effective, this kind of circular direction measurement. So now we have the same thing in beam routing. So beam modeling has becoming much easier because of that visualized beam beam insertion. You can easily get the correct direction, you can preview and others. A lot of faster than before. Then I'll press play. Do you know how to press again? Okay, now. Very nice new feature. Looks small, but it improves a lot of document production. A section view where with just a small couple clicks you are easily creating a section view to the documents. All these are minor things, but together it comes to the same conclusion that our new 2D is much faster than others, not our old, but others as well. As you can see here, he just with a couple clicks, he got the section, it makes section markers, the section markers comes, the section view comes correctly, very fast. Okay. And last but not least, we already have got a long time laser scanning possibility. That has been a long time. Now we have really nice new features in eShare and in our design tool to reduce the point cloud dramatically. You have used that one scan cloud, only one place scanner take picture takes 1 gigabyte size, very big. That 1 gigabyte, we are able to make it 50 megabyte. That means that you can fit everything in your own machine easily. This brings so much more capability that you can, even with new chip design, you can go fast scan and you can compare that the output is same as what has been designed. Even with new production, this is very useful. Thank you very much.